Hello, hello, hello. Howdy. Today we are here with a learning stream. Yippee! Today we will be playing While True Learn, a nice, fun, small game about machine learning and AI. I want to do learning streams more often, but it's kind of hard to do some things with code, and a lot of the things I want to do require me to share IP, and that's not really fun, so until I figure that out, we will be playing some games like While True Learn, PC Simulator, or Electrician Simulator. Anyways, let's start a new game. I haven't played this before. I have some experience with coding, but yes, to become a programmer, you must master your art of turning the computer on. Press and hold the flashing triangle and drag and drop. Stun, press power, and you're almost a programmer now. Ooh, you power my monitor, my keyboard. We have a wireless mouse. Bingo. Computer is on. One more step to be a programmer. Back to basics. Bugs. No fun. Gotta get your coffee to work. Cat. The cat is a master coder. It's all been a lie. The cats. What did you do? Did you do that? Holy zeros, if only I could understand what this cat has to say. Guess we'll have to find a way to recognize your speech. Goal. Cat speech recognition to-do list. Alright. Sure. Google Google it on Cat Overflow. I like that joke. Stack Overflow. It's the name of the coding website with everything. Player name. Already taken. There we go. Okay. How to recognize animal speech. Hey everyone, can you believe my cat? That little devil has debugged my code. Again. This has happened before? Oh no, I fucked it. The audio wasn't on. I am so sorry. This is already really scuffed. Damn. Well, now there's audio. Hey everyone, can you believe my cat? That little devil has debugged my code. Again. He definitely has something to say, so I decided to make some sort of system. Algorithm? Which would help me understand him. Give me advice, wish me luck maybe. P.S. I'm not insane. My mom had me tested. Same. Don't rush ahead of yourself. Making a device to be able to detect a cat would be a nice start. You can work with videos, sounds when the time is right. Hey, a couple days ago I've been reading about how expert system can now be applied for detecting animals and writing chatbots. The newspaper was called Deep News. I'll be sending you my copies once I'm done with them. Okay. Well, this'll be fun. Welcome to your workspace. This is where programming magic and bugs, mostly bugs, are born. To begin, drag an expert system node from the list on the right. Okay. Communication line from starting node to the expert. And right mouse button to delete. Okay. And then I'm guessing photos with cat, photos with no cat. Check to see if it runs properly. Photos with cat, photos with no cat. That works. Speed this up a little bit. Bingo. Hey again, I tried that expert system and it hardly makes any sense. Squares are floating from left to right? Is that what the fuss is all about machine learning? Are you guys actually working there? It's called visual programming, my fellow dude. Yes, this is how it's supposed to work. Expert system analyzes your data input from the camera and checks if there's a cat on them. No, it's what machine learning is all about. It'll get hardcore soon enough. I'm not very good at it yet, apparently. When do I actually start building a cat translator? Don't rush it. Gotta master your machine learning ninja skills first. Working as a freelancer and the amount of contracts is crazy. I'll forward you some jobs I don't have time for. It'll help you get on your feet and earn some cat bucks as well. P.S. You're still paying for the servers, though. Yeah, servers are pretty pricey. Noob advice. There's an auto help for each new technology. Very convenient. I've turned it on for you now. No need to thank me. But you probably want to change your password. My cat talks 123 is pretty obvious. I see. The task tree. This is the map of your progression in the game. Vertical progression stands for story quests. Horizontal branches are optional. Icon colors stand for different types of machine learning text used in respective tasks. Sounds pretty simple, or so we hope. Let's see, Spanish school at cat.meow. Good day, we're from a public school. Summer exams have ended, the results are attached to the letter. Could you process them and predict which of these students will be able to enter the MIT? Okay. This is... Okay. Proceed. I get 350 cat bucks from this. So, expert system, if green, go here. If blue, go here. Drag that there. Can I... No, this node compares colors. If the color is equal, the element comes into the top. Others go to the bottom. Before the invention of self-learning algorithms, people used expert systems. These algorithms tried to use hard-coded comparisons, similar to human experts' decisions. It worked terribly. Yeah, sounds about right. It's just a bunch of if-else statements. Let's test it. The server's $2 cat dollars a second. Dang. Release the program to complete the task. Mission accomplished. The cat cloud costs 42 cat dollars. Darn. Errors in database. Hello, we have some questions in our questionnaires data. We can't solve the problem by ourselves. Can you please fix? Okay. That should be no problem. Let us begin. Your efficiency is measured not just by money, but with medals as well. Medals influence your story progression while boosting your self-esteem. Shiny new medal does feel good. To get a medal, your scheme has to meet the respective time and node limits. You can improve your result later on. Trash can destroys elements. No matter how many you place, they will count for one node in the node limit. That's good. Real data sets have a lot of errors. Filtering out errors is a very important skill for all data scientists. True. So we want squares. And there you go. We'll do 2 of these. Do red, green, and then trash. Red goes here, green goes here. Move this down here. So, all the blocks go in here. Red immediately deposits. Then green goes down here. And green deposits. And then all the blues should end up here. Oh, nodes limit 3 out of 2. So no trash can. Will this work? Boom. It's maxed. Yeah, so blue. Let's try that again then. Did I get gold for this? Let's just double check this. Alright. Yeah, my blue deposit is full and the greens are not depositing. It's a silver medal though. Okay. No limits is 2. Ah, I get it. Yes. We'll filter out blue. Put the trash can up here. Connect this. Put that there. All the blues go in the trash can. Everything else goes to output. Bingo. Wonderful. Cat. Oh, cat make sound. Drawer. Wait, what? What? Alright, I'm gonna need to hop off for just a second. I'll be right back. Well, this has been a very scuffed thing already. Damn, talking to no one. Bought a plant. Read this out loud. Yeah, we're back. Custom nodes are special nodes containing your previously designed schemes. Press on the middle tab to switch to Customs node list. Okay. Ooh, drag the custom node, sorting the color right to the workspace. If you want to modify the scheme inside the custom node, double right click on it and press the down arrow icon on it. So double right click, press down. Okay. Let's drag this here. And inside this node, all inputs red top, blue bottom. Put that there. That should work right there. And that should work, honestly. Yep. Bingo. 58 cat coins for the cat cloud. Darn. Ooh, decision trees. How to recognize a cat. Works with text, but with pictures not so much. Furthermore, the cat just won't sit still. That it does not. Try decision trees then. Those are like expert systems, but on steroids. Once you feel comfortable around them, try Sift. This little devil is way more effective with pictures. Also works nicely when paired with other algorithms. Or you can use nails or glue or something. Come on, it's just a cat. It won't fight you back. I'm joking. Please don't use anything I mentioned on an actual cat. Please don't hurt your cats. Cats are nice. Different nodes have different processing rates. The parameter will influence efficiency of your schemes. Icons on the right indicate the amount of time required for a node to process one element. So now we have decision tree color. Compares output parameters, the sockets with an element's color. The element color is equal to only one of the sockets, the element moves to that sockets. If an element's color satisfies both, it goes, or none, it goes to a random socket. Decision tree is one of the most basic machine learning algorithms. Each tree knows a limited number of classes. For each element, the tree asks some questions and chooses the class most similar. Yep. Seems doable. So just one of these, I guess, would work, because this is fine with both green and blue. So green can just be left alone. And let's do it. Bingo. A decision tree is a smart tree. Huh. Let's try Medex. Nope. Who invented the decision tree? The decision tree is one of the automatic data analysis methods. The first ideas of creating decision trees date back to the works of Hovland and Hunt in the late 50s of the 20th century. However, the fundamental work that gave impetus to the development of this direction was a book named Hunt, Marin and Stone Experiments in Induction, published in 1966. Cool. Alright. Bye from Medex. Greetings. Our company is manufacturing all organic natural painkillers. They are used to decrease suffering, mood improvement, and coping with eating disorders. Known side effects include dilated pupils, diarrhea, and physical and mental addiction. Okay. Are caused by the human factor. From time to time, our workers pick the wrong plants because they look like medicinal herbs. We'd like you to design an algorithm that would sort herbs by petals' colors. Alright. Increase and decrease speed. Yep. So, let's see here. We have 3 nodes. Can put this here to start. Red and blue. And then we can also we can do this. Blue goes in there. Green can go to all of them. And we have a lot of green. Red is the main thing. So red can go here, else green can go here. All the red's gonna go this way though. So you can put all the green here and all the blue here. Because the green will sort randomly. So let's hope this works. Let's try it out. Yep. Okay. It works in theory. But I need to change this to blue, which goes out the top, and green that goes out the bottom. Let's test it now. Let's try this again. Let's sort blue out first. This is any. Blue goes directly here. Decision trees, any color. This can split off. And there we go. Let's try that. Ooh, yeah. Well, we have 3 nodes. So, you can make red go above, green go below. You can move blue to go into here. Red also goes above, green goes below. Let's do this. Red goes here. Blue goes here. This is what I had at the start, basically, right? Yeah, this is what I had at the start. The problem is blue does not get filtered fast enough. If red, go top. If blue, go bottom. I guess I need an expert system in the middle here. Say only blue goes here while green goes here. Does that work? Because this will fill up very quickly. No. Yeah, there's no time for that. Maybe another decision tree where blue goes here. Green just goes down. All blue basically needs to be filtered. Yeah, I'm just shy. Yeah, so green is the one variable that we don't need to sort. Maybe I put red down here, so blue for sure goes up top, and red for sure goes down at the bottom, and green can sort in between. Yes, no. That doesn't work. I can do one more node. Is to guarantee green here. This will fill up fast. Okay, let's put green here as well. Now let's try it. Decision tree split. There we go. Yep, we just needed one more node. Bingo. Achievement unlocked. Error stack overflow. I am curious what that achievement is now. Save that. Bingo. Let's take a look at the achievement. Complete a task with unlocked trash can without it. Okay. Buy an interior, finish a level. Let's continue. So, optimization. Hi, it's us again. We hope it's our last request for you. We've changed our database system. Can you update your code one last time? We need it to work faster. That should be no problem. Can now just do this. Red, trash can, boom. Oh, wait. I also need to put red, green here, just in case. Ha ha ha, you little tricksy. Put the 2 trash for blue and green, then red for sure by itself. Let's try it. Yep, there we go. Alright, next mission. Illuminati Origins. Good day. I study ancient manuscripts and books in order to find out the true story behind the Illuminati Secret Society. Of course they do. I need to recognize all the triangular shapes in these documents to solve the puzzle. Could you design a program that would do that for me? Sure. Sift. This node compares shapes. If an element's shape matches, goes to the top, others go into the bottom. Scale invariant feature transforms, one of the most powerful non-neural algorithms for detecting features on pictures, which is essential for image recognition. Alright, let's try it. This is all shapes. Triangle here. Ooh, but that's a lot of processing time, 1.25 seconds. Let's run it. And there we go. We are good. Let's release this. Bingo. Working for the man feels too easy, boring, or soul-sucking? Aim for the sky and become a CTO of a startup. In the world of savage market laws, it's either sink or swim. Will you get rich or bite the dust? It's worth trying anyway. The Pizza Shack. Okay. Let me just do something real quick. Da-da-da. Everything's pretty good. We can do a startup that is Pizza Shack. Startup. I apologize for that. I was posting to Twitter that I'm live now, which is something I forgot to do. Boom. And that is posted. Bingo. Now, let's resume playing, shall we? Pizza Shack. Mama Smith's Pizza Shack. Hello, we're honored to invite you to join our startup, world's first AI-controlled pizza place, but our fingers are always stained with flour and we can't really code because of that. Help us write and implement an algorithm that would be capable to separate orders for round pizza from orders for square-shaped pizza. Let's feed the people and become rich. Alrighty then. Nerds? Okay. Our first startup. A scheme created while working for a startup does not differ from any other. But there is no solution to startups. A scheme just works better or worse. And your future profits depend on its quality. I see. So we can just do this for now. Test run it. Program seems to be working fine. Further testing won't affect your results in the startup. Feel free to stop testing now. You're trying to design an AI-controlled pizza place. It serves pizza in round and square shapes. The scheme you're designing is the brain of the pizza robot. It sorts orders by the shape of the pizza that your clients order. These are the users of your startup. In this case, your pizza restaurant. They've heard of an amazing place in town and now they want to grab a slice. These are your clients' orders. The millennials don't care too much about toppings. Only shape matters. Sure thing. Mind the accuracy. If the client gets a pizza they ordered, they'll pay you the money and tell your friends about the place. If they don't get what they want, they refuse to pay and don't expect them to return with friends. Gotcha. One more thing. Clients don't like waiting in queues and they will leave with no hesitation. If your scheme is working slowly, the waiting line will get longer. Market's constantly changing, so pay attention to what's going on and experiment with your schemes. Now time to launch your first startup. I guess release this into the wild. This action deploys the code to the servers. From this moment on, the startup will work automatically. Gotcha. This table is your principal source of information about your startups. Press next day to proceed. Very well. When you switch to the next day, you get the money you've earned or lost, depending on how many user requests were processed by your scheme. Hey, look, your users seem to like what your scheme is doing. They're even inviting friends. Cash is flowing. Hype icon is great. Green? That means your startup is all over the news. Expect lots of new users. Bingo, bango, bongo. Today, your shares cost 600. No, I don't want to leave the startup. And patching is changing the code? Gotcha. That makes things interesting then. Now. Hardware. This is what I need. Increase sockets processing queue by 3. That's good to have. More FPS for the FPS god. I like that. Increase data transfer speed by 1%. Small, but it works. It's a tambourine. Rentium. Increase nodes work speed by 1% and data transfer speed by 1%. It's also good to have. A Viking cat. Or cyborg cat. Alright. Hehe. That was lightning. That is not something I expected. Alright. Lamp. There's so many buttons to click. Coffee. Cat. Oh, yep. Letter from Mom and Dad. Ooh. Hello, dear. We remember how you cherish your financial independence. But come on, your birthday is just around the corner. Be a good kid and take this money and buy yourself something nice, will you? We love you very much and we miss you. P.S. Don't forget to put a hat on. It's very cold outside. It's very rainy right now, to be honest, but sure. A cat marine? It's a Banhammer miniature? That is beautiful. Warhammer reference. Cactus. Ooh, I can either choose cactus or aloe. Keep the cactus. Touch the cactus? No, I cannot. Alright, let's continue. Yep, we're all good here. Tree. Decision tree equals a smart tree. Chicken escape. Hi there. Well, ready or not was a challenge. And it was my first stream with a crappy mic, crappy setup. Me not knowing what I'm doing. I want to do educational streams. They're pretty fun. And, I mean, Electrician Simulator, PC Builder Simulator, this machine learning game, I enjoy them. Hi there, my name is Sarah. I own a small technology farm. Our distributors demand supplies of eggs of different kinds, and it takes a lot of time to sort them manually. That's why we've decided to automate the process. We have all the data about egg parameters, but we need an algorithm which will work without human assistance and with high accuracy. Ah, yes. This is going to take a second. So, I can do circles first that go all the way up. That's the added processing bonus. It's 0.12 seconds. Put the squares here. There you go. Just 2-layer system. Let's run it. I think tomorrow we'll do a Minecraft stream. I'm not sure if we'll continue with the same server. Why did this end up as a silver? 2 out of 9 nodes possible. Hmm. Can I like... No, I can only do one socket. That's 2 nodes. White goes up. Square comes out here. Triangle comes out bottom. Is this just processing speed limitations? Yes, it is. It's just processing speed limitations. Okay. Can I purchase something to help me with that? No, I cannot. That's unfortunate. We will come back for that gold. Crowd psychology. Good day. Oh, Fightman Group. That's nice. Our company is making a research on crowd psychology. We need an algorithm which would be capable of defining a person's type based on certain behavior patterns. Yeah, that feels like a crime. This way we will be able to quickly identify dangerous individuals in the crowd and prevent unpleasant accidents. You have identified the parameters to work with. We need an experienced developer to write the algorithm. Okay. I see. So. Squares. Let's see. First thing we should do is filter out the greens. So I need 6, a triangle and square. Put square first. Then circle. No, let's be smart about this. Blue. Goes up top. This is actually kind of hard. Let's see. If we make it sort through greens first. Have it sort through greens. Then have it sort to triangles. And then I'll make this blue. And then I'll make this... So green and blue. Or I should say blue and green. This will then be green and red. And if red is a square, it'll go here. Else it'll go in the trash. Move the trash can like way back here. And green, same thing. It's a triangle. It'll go in here, and the rest goes in the trash. Nope. Everything up top is going to be blue and red. If it's a triangle, send it to the trash. Else there, does that work? Let's try it. 6. 100% right now. The sift is full. Please? Ah, just shy. Processing time, I'm guessing, as well. And occupancy. Time is passing by and the market changes. When hype icon is yellow, it means that your target audience is already aware of your startup. Don't expect many new users from this point. I see. When your hype icon is gray, that means you've satisfied your target audience. Users starting to leave. That's no fun. Watch your earnings carefully. When the number becomes red, it is time to cash out. Very well. We'll need better for the side mission. Good cat. So bronze and silver here. Gold. Cat mail. This should definitely work. Eureka. The cat has been detected. Bingo. Dawn of civilization. Animal emotions recognition. Hey, so I've managed to make my computer detect the cat, but that beast is a complicated soul. It definitely has more to tell. Maybe it's time to go to the next level and start recognizing emotions. Ever heard of perceptrons? They were invented in the 60s to recognize written text. Everyone knows that everything invented in the 60s is awesome by default. The double helix, rock and roll, and lava lamps. True, lava lamps are awesome by default. Also, you can maybe switch to dogs instead of cats. Decision trees work like magic for my Pluto. You can also hit the store and get that random forest node. A forest is more effective than just one tree, you know. And now for something completely different. Perceptrons can actually learn and improve. Bad news, they also make a ton of errors on the way. Use training mode to teach perceptrons and decrease the amount of errors. Okay. Perceptrons reduces the amount of errors while trying to predict the shape of elements. In test runs, Perceptrons only predicts shapes. Rosenblatt's perception used in Mark 1. This perception could recognize only simple linear dependencies, but it was enough to recognize English letters. Great. 60% accuracy needed here. Can we test run it? Okay. The nodes in the field have reached a minimum margin of error. There's nothing more you can teach them. So minimum margin of error is 20%. Ooh, I don't like that. Let's test it. Yes, 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 yes. There's circles going here. Bingo. Success. Nice. Alright. Let's go back to the tree. Dairy products. Hello, my name is Sam. I own a dairy products factory. My dream is to make the very best goods on the market, and that's impossible without high accuracy and fermentation processes. Alright, off with the fancy words. I want a program that would judge the quality of a product by its ingredients. We often make mistakes when doing it manually, and a lot of our products never leave the factory since we marked them as defective. We have the data, but we need the algorithm. Gotcha. Very well. I will give you circles, squares, triangles. Ooh. So maybe 2 layers. Does this work? I guess. Let's train it. Okay. Stop training for a second. We would like accuracy for circles only. So that's probably best there. Let's try that. Will it ever finish training? This will forever be at 100% accuracy. It's getting there. Takes time to train models. Took me several hours when I was learning. There we go. Nothing more we can teach them. Let's try it out. Everything else would go in here. Success. There we go. Project released. Metal Gear Construction. Hello, we're Metal Gear Construction Factory. We produce fittings and supply raw materials to construction grounds all around the world. We're especially proud of our high standards of quality. At the moment, we received a lot of new orders, and we are running late with the deadlines. An algorithm is required that will analyze the quality of raw material and discard poor quality ore before it leaves the conveyor. Manual analysis takes way more time than we can afford. Alright. Wonderful. Let's start it with a perceptron. Triangles go into this, where red goes in the trash. Put both decision trees through here. Red goes into here. And blue goes in the trash as well. We can add another decision tree here, just to filter out the green. Red goes down here. Yep. Let's train this real quick, just to check how it works. Okay, this one has not been tested. It needs to sort. Let's test run it then real quick just to check. I have a lot of loss here. We could probably scale it here. Boom, boom, boom. Add a Mark 1 Perceptron here. Blue and green can go into here. Triangles go there. Squares and circles disappear. So everything coming here could also be green. So that will reduce waste. Triangles go here. And then this could be a secondary filter where red goes into trash and green goes directly into here. Let's try this out. Let's train it real quick. Just need this perceptron to generate. And all the blue and green circles should go here. Squares and circles. I need green and blue triangles to go down here. Just as a secondary filtering operation. Run it one more time. Boom. Let's test it. Slot 100. Nope, there we go. Launch failed, you ran out of time. What if I move this back here? Let's break all of these real quick. Triangles go here. Squares and circles go here one more time. Triangles come out to guarantee we get the triangles. Red goes straight to the trash can. No. Incorrect. Blue goes directly in. Because blue and green works. Red goes here. Green goes in. Red leaves. Gets disposed of. That should filter out all the green and blue triangles. As for this, if you run it through here again, circles and squares go here. Red goes... I need double layers for it to work. Red goes here, and all the blue and greens get filtered out because they are not needed. That should work. Test run this. If this doesn't work, it could just be a matter of processing power and time. Yeah, this is just mainly a matter of processing power. Dang. Alright, let's try another tree for now. Reinforcement learning. Hello. We is a society of peoples who love cats. We wants our cats to has all the best. We want cats to drive cars with no humans inside. But cats have no hands, cats have paws. Can you make a car that self-drive? Yours, Dr. Meow W. Cas, human person. Please excuse our grammar. We are not cats, we are humans, but we can't type well because we has paws and no hands. Terrible car accident, bad surgery, is why we need a self-driving cars, haha. That hurt, reading. Reinforcement learning tasks nodes work in a bit different of a way. All data is initially unspecified, and your task is to recognize it and transmit it to RL agent. Get the unrecognized data on the input and classifies them as either an object or as a road. Gotcha. Sift. Scale invariant feature transform. One of the most powerful non-neural algorithms for detecting features on pictures, which is essential for image recognition. Sift is very fast and is capable of recognizing simple objects and patterns. Wonderful. We do this, and I guess process it there. And that, yes, that, okay. On this screen, you'll be training and testing your AI. AI acts based on the data you've been recognizing when building your scheme. Gotcha. The data about surroundings on the road is processed from the scheme to the machine learning model. Your car won't be capable of learning and detecting obstacles without it. The goal of this type of task is to make the AI clever enough to be able to reach its target average speed level. Press supervised learning and drive the track yourself to teach the AI. Be careful, the car sees only objects inside a LiDAR area and only learn from them. Gotcha. So, launch training so the machine learning algorithm will try to reiterate your actions. So the moment I detect object, start move. Detect object, start move. Detect object, start move. Press training and watch the car's AI try to reproduce your actions. We hope you've been driving safely in the supervised learning stage. Oh boy. Evolve. Your model has achieved the target speed level. Press test and enjoy your results. The result isn't good enough, try training the car again. Press test to proceed. Yep. Yep. That works. That works. Huh. Increases respect from developers. Yep, thank you, devs. And sell. Startup is closed for Pizza Shack. We're no longer in a negative. GG, rip Pizza Shack. A self-driving car startup? Wonderful. We are aware that you were able to create a text recognition system based on the Rosenblatt perceptron. We need a similar system that would also be able to distinguish vowels from consonants. The task is simpler, but more accuracy is required. Gotcha. The first perceptron machine neuron was invented by Frank Rosenblatt in 1957. Frank created Mark I in 1960. Mark I is a perceptron machine that can recognize English letters by their shapes. Cool. So, squares and triangles go down here. we have one node. It's absolutely wonderful, to be fair. Let's train it. There we go. The nodes in the field have reached a minimum margin of error. Let's go. It takes a while to process. There we are. Gold. Alright, cat doing his own thing. Let's do a self-driving car startup. Hi, we are trying to launch our self-driving taxi service. It's a very promising startup, but we have a problem. Our algorithm makes a lot of errors when it tries to recognize traffic lights. As a result, the car sometimes moves instead of stopping. We hope you can solve this problem. The code must be working very fast. That is a problem. Sure. I'll invest money into this. Don't need to train your nodes while working on a startup. They already have the minimum margin of error. Because time is money. Gotcha. So 50 of these. Let's see. Let's test 5 first. Triangles keep going down here. Circles and squares end up at the start. This is the very first iteration. First triangle goes down here. First triangle found. Re-enter the system. Circle and square will go back up here for filtering. Triangle found will go directly in. Circle and square goes here for filtering. Triangle goes here to check. Test it. %90 accuracy. It's a tad bit redundant. But it does have a tendency to jam. Okay. Let's do it like this. This is a fallback. Triangle step 1. Triangle step 2. We're going to make this the square. Square is detected, it goes here. Square is detected, it'll go to the start of this. Squares continue on to here. Or they continue on to here. Circles will fall back here. Circles will also fall back here. Triangles will go back here to the start. Same thing here. If it fails, it'll restart. Circles continue on. Squares go here. Triangles go here. Circles go to the finish. Circle goes to top. Square goes to here. Should eliminate some redundancy. It's kind of complicated. Yeah, let's test it. There's quite a long delay, to be fair. But hey, accuracy's high. Let's hope this works. It's not always possible to satisfy all our customers in one day. Users with unfulfilled requests are shown in red color. You don't have the instruments to solve this problem for this startup, but you'll get some to handle the future ones. I see. Money, baby. I'm rich. I can finally invest. Nope, I still can't invest in a Warhammer miniature, a Banhammer miniature. Should be fine. Yep. Let us now do parallel calculations. Hello, we represent a scientific center. Our current programs are underperforming. Can you parallelize our calculations? To process data, your nodes need a computing power, a server. Certain nodes require more than one server. Oh no. The more servers you use, the more expensive your scheme becomes. This node routes elements to the least overloaded socket. This node requires additional server power. A load balancer is a device that distributes network or application traffic across a cluster of servers. Load balancing improves responsiveness and increases the availability of applications. This is why we don't crash a lot of the times. Let's do this here and here. And that should go fast. Boom. But it's semi-expensive. Nice. We're still doing good here. Sales prediction. Good afternoon. We just bought a stock of trees for the holidays. Friends say you can calculate the peak demand period for them. Please help us. No problem. One node with 100% accuracy. So any in green, I guess, would be the best. Let's run it. There we go. That works. Ancient artifact. Good day. Our group is working on finding an ancient artifact called the Tesseract. It is a very unstable element which radiates energy in different specters. We have almost found it, how to use its power to benefit humankind, but we need a smart algorithm to separate and to direct the flows of energy correctly. Revolution in energetics is just around the corner, my friend. Very well. Can put this here, the load balancer. That's probably what they want us to do. 2 decision trees. So green and any. Any can go here. No. Let's see here. I need to filter out the reds and the greens. Red goes here. Green goes here. guessing the first one goes here. Will this work? No, it does not. I think that's a trap. Red any. Blue any. Let's try it. Ah, but we lose all our red here. This is actually kind of hard. We route it through a balancer. Green goes up top. Red goes to the bottom. And then for this one, red comes out on top. And then green goes down to the bottom. Yes, let's try this. Is that gold? That is a gold. There we are. Self-driving car is still doing good. Increase sockets processing queue by 5. Thank you. And decrease server costs. Bingo. Nice. Let's see, can I still do this? So, let's look at the load. Squares first. That's the bulk of everything. And circles next. Triangles last. Is that the issue I had? Maybe I do triangles first. Those take the longest to process. And then circles because they're next, and then squares because they're so common. It's usually better, no? Yes, it is. Bingo. And now we're at deficits. Bye-bye, startup. Crowd psychology. Let's try and get all gold here. So as of now, The main issue would be the sift word in blue here. So the red goes up there. All the green triangles should end up down. That should work. Nah, but this one then gets congested. Maybe I do another sift here. Yes. The red goes here. If it's a triangle, purge it, else put it in. Tad bit full. There we go, gold. It wasn't a processing issue, it was a skill issue. Yay! That should mean I should be able to do Metal Gear construction. My issue here is... Is it too much redundancy? I have a lot of percentage I could have for error. Now this is making sure I only have red. If I remove this to direct to red, that work? Let's change this to blue then. Because blue is the one that has the most. So if I can redirect blue, the greens will reduce it less. Let's test run this. All the green blue triangles are ending up here. No, still just shy. What if I don't need to double process it? That's my main slowdown. Squares and circles go directly here. Should speed it up significantly. Increase the margin of error. So let's see, to get 35. If I do it like this. Let's add this at the very end. Red, blue. If I do this, the other two go in the trash. We train it. This will get full very quickly. What if I had another thing taking away some of that? Should be better this way. This still gets full very quickly. I could have it divide. So all the green goes up here, all the blue goes on here, because there's a lot of blue. Let's train it. Everything's good. Let's test it. Higher degree of accuracy, not fast enough. Yeah. Metal gear construction, still not perfect. It's better. Still not perfect. Any tips, ideas? Currently, I'm drawing a blank here. If we just send the red in without filtering it, what happens then? We can increase our accuracy. It's close, very close. Keep pushing the wrong button. 28 seconds. That's what we need. What if I don't filter green? Is that too much for inaccuracy? Because there's a lot of blues that need filtering. Yeah, it's too inaccurate. What if I only do one set of green being filtered in? Take the other one as full leap of faith. Trust it. It might work. Alright then. Not the most accurate, but it worked, I guess. I'm curious, what is that achievement? Better than developer? Alright then. Why do I have a feeling that mission was not meant to be completed? Howdy, I'm contacting Howdy, hehe. Nuke your toy. That's unfortunate. Howdy, I'm contacting you on behalf of Nuka Toy Company. We design and manufacture toys for children using 3D printing technology. There are 3 types of raw materials we use for printing, and we need an algorithm that will distribute them correctly. Passing a certain error threshold could result in a disaster, so watch out for those. Let's see. 2 input streams, 4 possible areas to look at. So something that would need that would be here. Yeah, I'm going to find a way to do this one. Should work. Let's train it. Is there any way to improve on this? Don't know anything from now. This last perceptron needs to finish up. Let's test run it. A very small margin of error. I don't get a lot of time here, do I? No, I do not. I'm short. One here. Let's move triangles down here. Test run this. Accuracy goes down a tad bit. Oh, I'm just shy of... Okay, no, this one's a tad bit short. Where's the minimum? The triangles here are minimum. Move that there. Test run this. I don't know. Yeah, the middle one's just a tad bit shy. Let's see. How do we do this? Maybe not the second filter. So the circles go up there. Second filter might just slow it down. It's the bottom one, okay. Any errors go down here. Should be able to send it to so the bottom one gets completed, but not the top one. I see. What if I move this one all the way up here? Yeah, I think that's what I need. It's all filling up steadily now. A few errors would go into here. Oh, I'm just shy. Need 44 seconds. Okay, yeah, so I'm getting close. Let's try that. So I changed this to go direct. Doesn't have to filter. Okay. This is the last one. If we just do that. Just 2 nodes. Some degree of error is acceptable. Ran out of time. Okay, so square's the highest, it goes down here. Square's the highest, it goes down here. Triangle's the highest, we go down here. This one's shy. All the triangles here. All the circles here. It's bound to be some errors. But this is the main concern here. This is like too short. What if triangle that goes here? This no. Square goes in here. This square comes up here. Search this out. No, this is even less. This square needs to go here. This circle is what needs to change. This circle goes up here. Okay. This should be good. Just need to train it. Yes. Just train it real quick. I don't need it to be perfect. I just need it to do enough to fill this with circles. Let's test it now. That's good enough, I think. Check. Just shy. Check triangles for circles as well. Maybe this will work. The buffer is usually clear. That's brutal. Now let's test it. For 0.5 seconds away. Man. So close. Again, 0.5 seconds away. Test this again. The last one to fill up is always the circles, right? No, it's the bottom one. RNG is my friend now. No, it is not. Triangle down there. Test this. The square should end up here. Yep, so let's put the squares down here in the middle. Just in case. Check. No, I'm just shy for this one. I'm genuinely confused. Oh. Maybe do I train it like to 20%, like fully? Is that probably the best? Okay, test it. Let's hope this works. No, we run out of time. This has a lot going into it. Did I filter this out? Put the triangles here, the squares down here. Just need to balance it out, but it hurts. No. Bottom one. send the triangles directly and put the squares there. Let's try that. Oh no, I'm just shy. 48.3. 2 seconds over. Triangles can go to rect, and we just put that there. Generally do not know. It's kind of... This mission's hard. So all the squares and triangles are going in. It's 57. Theoretically, no. It's still a large number. No, this isn't... Wait, send this directly there. Send this down here. It's gonna have a higher margin of error, but it's direct. Bottom. Okay. It's all the bottom. Triangles there. Like, this is how it was originally. What if... Triangle. Go. Make the circles... The circles are very inaccurate. Let's train it a bit. Not all the way, more like... There you go. 50%. You can get most of it right. No, it's just accuracy. Okay. Let's try that. 47%. What if I move this forward? Put that in here. And then triangles in the middle. Train it a little bit. Now test run it. You can get circles fairly high, supporting the other two. Not enough. Okay. Let's move this here, this here. Square and triangle. And now test run it. Make sure every one thing going to the circles are circles. Triangle squares here, circles here as well. Now test run. Let's do this. Circles here. Square triangle here. No. Triangle here. Square here. Square goes on here. Triangle goes back into here. Circle goes there. Test run it. Train this just a tad bit. There we go. Now test run. Keep some RNG in there for it to work, hopefully. These all need to go down here. This needs to fill up. The middle fills up very quickly. It's the bottom. Now let's test run it. Bottom's filling up a lot faster now. Please work. More. Cycle through. No, that's sort of too much. I can only do 4. Send the square in. Get that out. Let's see what fills up the slowest. And from where. Bottom now fills up. Oh no, that's so close. Train it ever so slightly. Let's see here. Mark 1 perceptron. The bottom fills up quickly. That took all the time. Huh, that's what the sound's from. So, instead of all of that, we put that there. We have 3 streams now. Just shy. If the triangle's here too. Question is, do we make this too slow? Yeah, we do. Put the squares here. We test run it. This becomes too slow, I'm pretty sure. Let's test run it now. Change some values of training models. Maybe too many circles. That might be an issue now. Because the circles are highly trained. What becomes a slow point? Is it the circles? Yeah, the circles become the slow point, and this becomes in excess. Test run it with some training. Yeah, I'm just shy. Test run this. Circles fill up. It's just this part left. Okay, so if I move this here. Nope. Can't move that there. The triangle there. Because a majority of it are squares that are going down. It worked! 0.6 seconds! Wait, yeah. There we go. Hey, we did it! Hell yeah! That took a while. Alright. Now, large parallel calculations. Hey, our parallelization system is broke after the last Doors OS update. Blech. Can you fix it? It's a very big system, be careful. 1969, Seymour Paper Marvin Lee Minsky wrote a book called Perceptrons. This book, they spoke about math constraints of the first perceptrons, the XOR problem. This book has shifted the scientific interest in funds distribution from the US government orgs, slowing down the progression of machine learning for almost 30 years. The expanded version was released in 1987, containing chapters that disproved the statements, the remarks made since 1969. Oh dear. Do I do this? There we go. 1, 2, 3, and then split it up even more. Just a simple blitz. Yeah, alright. Let's see here. Dictatorship. Oh, that sounds fun. Greetings, this is the only state internet provider of a small country. We have a rather suboptimal code to track our people's activities. Unfortunately, we cannot allow you to change the actual code, but we have several new servers purchased on a garage sale. Parallel the calculations, this will help our tyranny prosper. These are CatHub repositories. They store previously made schemes and allow switching between them when required. You can choose a version of the scheme which will be used as a custom node. CatHub repository. I love that, actually. Holy. So we do 2 bouncers. Four of these. Bam, bam. Bam, 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 bam. Trash can for everything that's not red. This is, I guess, how they want me to do it. It's gonna be full. There we go. We help the dictatorship. I guess. Oh. Increases nodes work speed by 3%. Yes. Provides DLL slots. Yes. Decreases server cost. Yes. All of these are great upgrades. Beautiful. Alright. Let's do Tatari. Good day. We are inviting you to join our hacker startup. We write cheats and guides for different games. But now we would like making something really cool. We need a program that will play and win an Arkanoid instead of the player. We know that you know a lot about machine learning, so we are inviting you to participate in our startup. Let's join. So red, blue. Ooh, you can copy paste nodes. I did not know that. Alright, let's try and do this then. We'll set up one side. Red, green, green, blue. So red goes in here. And let's have one that just sorts out and brings you into the trash. Green just goes in the trash can. Blue just goes here. And red goes here, blue goes here. The trash can. And we can repeat this. Down here. Go up here, go up here. Bam. Test run. %, accuracy. We disconnect this. One, two, three, four, five. Just do that. Can put 2 balancers in. Bang, bang. Should dump loads of data in. Yep. It does take a gigantic workload. For real. The screen can go here, and the screen can go here. I can delete this node. Should be fine. These will fill up quickly. Maybe release it like this. Let's test it real quick just to make sure. The code's working good. These are balancing the load just fine. Probably combine these down or go here. Same here, combine this down. Let's test it. Let's release it as is. See. Oh, that's a very big deficit. I'm gonna be completely honest. Just gonna remove one path of this. There we go. Major profits. Now let's do new production. The best clothes. Top of the morning to you from Zimiletto Outfits. We're trying to optimize our production lines and we need a system to distribute textile by material, send them to their respective conveyors in equal amounts. Believed you could nail this job, so we look forward to hearing back from you. Gotcha. Darn. So okay, so this is a decision tree shape. Anything with a square is gonna go there. Circle's gonna go there. Just gotta paste that. 1, 2. put the bouncer here. Just run this. Is that enough time? Sec. So you need all the circles to go up there. Yeah, I may not run out of time. I add one more set. Put another bouncer. You can do it like this. Right. I need only 4. I see. So if I test run this, let's see. 2, 1, 0. Best I can do is hope for that one. At the bottom, best I can do is that. Yep, there we go. Any new fancy thingies? Nope. Lots of monies. Treat. Tatari's what's working right now. Secret information. We are a secret military organization. Our code name is Protoss. Everything you're going to read further is classified. Our analysts are sending operatives to various war zones. An escalation of conflict with the enemy has recently occurred. We are in need of a self-learning algorithm capable of sending dedicated units to respective parts of the battlefield. Alright, thought process here. Green else up. Then we run this. Maybe works. Okay, the expert system, pretty bad, I'll be honest. Green here. Red can go up. Now let's test run. I forgot it's short. So all of the blue. Can this work? Hey, that works. The code doesn't look pretty, but it works, and that's the worst part about it, because that's coding in a nutshell. Ooh, let's do Viking cat. Ooh. Little raccoon jumping all around. Oh, my ears. Can I play? Nope. Alright. Cyber Initiative. Our company's cyber initiative is into manufacturing androids. Our production lines are fully robotized. The only function which is still performed by human workers is logistics. We're shipping our androids to the government, military companies. We would like to automate this process with an algorithm that will distribute androids depending on their characteristics. Glory to the robots! So, let's see here. Our random dump will be up here. Blue and red are here. This is the key one, red. So I guess I need to start with a balancer. 2 export system reds. Or I can do this. Green, then decision tree. And this goes up here. Blue and green are 2 options. Blue needs to go into a balancer. To do this, we filtered out all the green. Which will then just go in here, I guess. Bang, bang. Blue can go in here as well. One more balancer here. And that fails it. No. Brain is not working like it should be. Okay, so how do we do this? Learning bit by bit. We're getting there. So we have the best way to do this. We have a lot of blues. You can do decision tree colors and then split them up. So this is green is the main factor. All greens can go up here. Actually, all greens go directly into here. Sort it like that. Blue then goes in here. No. Red then goes in here. Then it's sorted blue and red. Red goes directly in here, blue goes directly in here. And then let's test this for now. So this fills up very quickly. Do bouncer that sorts these out. No, I run out if I do that. Bouncer for the blues. The red fills up very quickly. Needs time to run out for me to get this to work and check it out. We're at 40 out of 27. So you can split the reds as well between the two. Let's test this. It's expensive. It's also not the prettiest, but it might work. No, it won't. Okay. Red is important in this one. It's expensive, but maybe one more of these. This may work, actually. This, as much as I hate it. No, it does not. What if I do it like this? Send it direct. No, I'm short up top. How would I do this? Because, like, all the blues go here. Let's assume all the blues 60, 30, 30, 15, 15. How would I do this, man? This confuses me. maybe less of the balancers. Let's do more sorting style. Do balancer here. Splits into 50-50. So 2010s. So randomizer. To make sure only red goes here. So I need to make a red filter up here. Put it down here. Red and blue. So the red filter goes here. And then maybe something to sort the green. Green and red. Then this will be blue and red. Red go down here. Blue goes to the 50-50. The green can also go into the 50-50, but send it direct to here, so because this is more. Then you make a green red filter for the bottom as well. So green red filter. Green goes up. Let's put it where there's more. Red goes here. So all the green is gone. It's just red and blue. I guess 50-50. Do any, it's a mix, right? So more red than blue here. Let's test it. I have time. More down here, more down here. Maybe this green. Need more red here. How do I do this? This really is kind of complicated, huh? No, that won't work. Put it here for 50-50. That may work. May not. Doesn't solve the problem at the bottom, but that works for up here. Yeah, having just blue is not enough here. Maybe this is too much. Just shy of 1. Oof, is it an RNG thing? No. Yeah, I'm just shy of 1. About this. Shy of 1. Convert this to red. Send that down there. Or convert this to any. Swap it. The fact that swapping it works annoys the hell out of me. Sure. Sure, I can't even complain. That's just pretty dumb. Alright. Prediction of presidential elections. Good morning. We're contacting you on behalf of Yahoo Corp. President of our partner venture has been dismissed last month, and the board of directors is in the process of electing a new one. We need to be able to predict who will win the election so we can make a decision about the future of our partnership with said venture. Make it happen and you will get a handsome reward. $1,000 ruse. Control C, Control V. Yep. But I did click and hold. That didn't count as copy pay. Yep, so this is just, I think I made this a while ago. So like this, red, green. Red goes here. Keep a trash can in the center. Green goes directly in. Blue goes directly in. And then roll Z. Roll V. Red goes here. Get rid of this. Green goes down here. Red goes here. Balancer 1, balancer 2. Test it. I did not set the red. Now let's run it. Yep, there we go. Automatic movie star. Tracking system, predicting the sales, and Amazon. 40% done. We're getting there. One way or the other. Hello, this is from the Oscar Committee. We want to replace some of our experts with a neural network. Please design a system that could rate movies by their type. Sure. No problem. Maybe problem. green go here. Green go up, blue go down. With a bouncer in the middle. Nope. Hmm. Yeah, this is the only way you can actually feasibly do it. It's the bottom parts, just... Maybe one of these here. So the reds also go down. Yep, there we go. Nice. Nice. We're making money. A lot of it. Machine learning will help the animals. American scientists have managed to develop a computer method for detecting the toxicity of chemicals, which is more accurate than animal testing. To create it, they used binary similarity coefficients. The system itself was trained on information about more than 866,000 dangerous properties of chemicals, commonly used in different experiments. I wanted to do a project like this once. Then I realized someone already did it, and it made me sad. Quite sad, to be fair. Tree. Let's do... Everything below here is done, right? Yeah. Tracking system. We represent our glorious democratic leader, Admiral General President Ali Baboon Petrov Boshi. Legitimate ruler at cat.meow. Okay. In his infinite wisdom, he offers/orders you to create a system that would process the recordings of kitchen talks of our beloved government critics. So they would be sent to our country's famous recreational camps. We will pay you from each individual who joins our national healthcare program, too. One last detail, you must only use technologies developed in our country, as we despise your Western technologies and we wish you all a slow and painful death. Have a nice day. Sure. I'll join the startup. Oh. Let's see. So in a sift system. Let's do one balancer. Sift systems. And then color sorting. So red would go up here. Green would go down here. Blue will end up in the trash. Else also goes in the trash. Okay. And for this one, to process green only. May need an extra node, I'm gonna be honest. Will this trash can here make it neat? So that gets rid of all the squares and triangles. Then red and green. I guess blue would be better. Blue and red ends up in the trash can. That'll work. Let's just delete this. 1, 2, 3. Control C, Control V. Same thing here. Red ends up here. Green ends up down there. Should work. C, Control V. I think I just need 3 balancers. Could be too much. Could be too much, actually, yeah. Let's just stick with this. And release it. I'm in a very big deficit. There you go. Oh, might wanna. So I need to scale this, don't I? How much larger do I need to actually scale this? How big of a deficit can I go? That's what the main question. Lol. Well, that's unfortunate. I meant that as a joke, but like, can I load it? Wait, I actually feel bad now. No. Oh, I can't load it. Damn. I can't save scum this. It's actually really unfortunate. National Heritage. Good morning. We have dozens of scientific equipment placed in protected areas for the sake of looking after the objects of national heritage. We're parsing info from our equipment on a daily basis and need to sort it depending on the color of their report. Can you make a program that will help us? Yes. Yes, I can. Red, blue. Red, green. And this will be blue, green. Send this in here, blue down here. Spiderweb. Should run just fine. Beautiful. Need harder ML job, level up maybe. Hi friends, it's me again. Thanks for these jobs. I can now afford a meal almost daily, but I need a kick-butt video card to proceed with my task, ergo need more monies. Am I ready for a more hardcore job maybe? Little coders grow up so fast. No problemo, my duderino. I'll send some more contracts your way with bigger data too. Beware, in these tasks you're allowed to make some mistakes, but they're way more tricky to crack. How so? This is real-life data science for you. Corrupted data, incorrect data, useless data. When it comes to big numbers, it's not about being 100% correct. It's about getting the job done, Sonny. Okay. Sure. Big data. Big data equal big mess. True. And I can go in CBay to buy more things. Increase work speed, DLL slots. Work speed, socket processing. Data transfer speed. And server costs are cheaper. Nice. Hey, what's up, buddy? How are ya? Listen, I know I wasn't paying you for quite a long time, and I'm very grateful that you weren't demanding for a paycheck for so long, but to be in debt, even to a friend, is not cool at all. Therefore, take this money you've honestly earned. Thank you, friend. You've really helped me out. And how about we go to a concert next week? That's nice. I wish I had a friend who would take me to concerts. Oh well. Gamazon. Hi, it's Jeff. I own a small online bookstore and I need your help in choosing a logistics company depending on a client's region and type of book they ordered. I would love to automate the process with the help of a special program. Offer you a share of the sales made. Please note the entire data needs to be processed. Oh lord, okay. Let's put some blocks down real quick. Bouncer down too. Sift of a square. Else can go here. And then we need color trees here. red, green. Same thing here, where triangles go down here and everything else goes up here. All blue can just go here. Put that here as well. The same lines. Now for the green, I just need a square sorter. Up here can go down here, this can go here, and this can go here. Test run it. Ooh, why am I not getting 100%? Blues, that's right. Blues do not get fully sorted. Blues need to go here where they get sorted between blue and green. And greens get put into there. Green gets put into here. Yep. And blue goes directly in. There we go. Now we test run it. Bingo. Release this. Okay, the hype is good. I just need another bouncer here to scale the system up. This, I can put this here. If I don't need this, I can put one, two, put that there. Don't need this one here. I can put this one here, this one there. Hatch, test run real quick. It should work without a hitch. Yep. Yeah, I might want to just leave that. Nope. There we are. Protecting the sales. Protecting the amount of sales for a clothing store. Hi, I have a clothing store and I want to know how much money I might earn during holiday sales. Help me. Alright. You can do this rather easily, honestly. Put a bouncer in the middle for 15 seconds. Boom, boom. There we are. Now we have 2 paths. All the red will go up here. Only green goes there. Then we have blue green, where blue can go at the bottom, green can go there. Let's just test to see if this works. Yep. Stop that real quick. There, test it again. One more time. And one short. Okay. Let's test this. Nope. That ain't it. Let's test this way. Yep, that one works. Alright. So that's everything. We've done everything up to the accuracy part. I think get a new phone and along the shelf. Okay, the cat says thank you for watching. I will be back tomorrow with some Minecraft if you're interested. And if you're watching this VOD in the future, thank you so much. Like, subscribe, do all the random things that everyone tells you to do. And I will be back next week to continue this game. Bye.